Hi, Honors Cam. The next type of problems we're going to do here are determining rate laws from mechanisms. So we're going to use the example that we did in class, and I'm going to walk through the example on page 641 of your textbook. So some of the vocab we're starting with here. Mechanisms are a series of steps, so we're going to first of all write overall reactions. We're going to take a look at substances that were created in one step, then destroyed in another. So those are called intermediates. Intermediates will not show up in the overall reaction. The rate determining step is the slow step. That's the one that's going to basically determine the overall rate of the reaction. So taking a look at what we did in class. In the Lego building example, we had a Luca step, a Ty step, and a Nate step. And based off of the way they behaved, they reacted, Ty was our slow step. He was our rate determining step. Okay, so the entire rate of the reaction was based off how fast Ty was working. Okay, Luca was fast, Nate was fast. So first of all, we're going to cross off intermediates and write the overall reaction. So Luca created AB, which was then consumed in this step. Ty created ABC, which was then consumed in this step. So those are all known as intermediates. And our overall reaction becomes A plus B plus C plus D yields ABCD. Okay, so that's overall what's going on. These substances aren't seen down here. They're known as your intermediates. Our rate law can be determined by the slow step. So, the mechanism can work as fast as the reactants given to it. So Ty was as fast as the reactants. So the reactants in the rate determining step go into your rate law. So our overall rate law is determined by our Mackay step. Concentration of AB and concentration of C. But because AB is an intermediate, it doesn't show in our overall reaction. This is an inappropriate rate law. We can't report that. So we have to find something to substitute for AB. So even though that's our slow step, we can't report an intermediate. But we can substitute that for our Luca step. We can put A and B in, first order in each, to represent our overall reaction. Substituting A and B in for intermediate AB. Okay. So this is the correct answer for the rate law. This is the overall rate law for the reaction. At no point here do you see any D. It does not matter how much stuff you give Nate, because he's working way faster than our Mackay step. We can also look at different proposed mechanisms and determine if they justify the observed rate law. So this is the example on page 641 in your textbook. It's also in the slides 72 and 73. So if we can take the reactants in our rate determining step and they match the rate law and the overall reaction is the same as the proposed mechanism, then that mechanism will work. So in A, this is our proposed mechanism for this reaction. It's the same one I used for the previous video using initial rate. We can cross off our intermediates, write the overall reaction, It matches our original reaction. The slow step is right here. So our proposed rate law is the reactance from the slow step. But because it includes an intermediate, we have to substitute in for those intermediate. It's a 1:2 ratio. So we can take that out, substitute this in. The coefficient 2 becomes our exponent, so it is second order with respect to the nitrogen monoxide. It matches our rate law. A works. Okay, A is a good proposed mechanism. Right. For B, we can cross off our intermediates. Write our overall reaction. It matches our observed reaction. And write our rate law from the reactants in the rate determining step. It does not match our observed rate law, so B is not a valid mechanism. That one doesn't work. Okay. C, it doesn't even balance. It gives you weird things. I don't know why they even gave you C. Okay, so C is a mess. We can cross off intermediates, but then you get all these weird things. It doesn't even match the reaction at all. D, we can sum, write the overall reaction. The intermediates will cancel. So the reaction matches. If we write the rate law for D from the reactants in our rate determining step, it includes an intermediate. We can't include the intermediate, so we have to figure out how we can substitute for that. We substitute it from the fast step, so we're going to put this in instead of our intermediate. So that becomes another, take this out, becomes another NO and an O2. So it becomes second order in nitrogen monoxide. And the oxygen, it matches our rate law. It matches our rate law. So D sums and matches, it works. A is a valid mechanism, B and C do not. There is a really good video that I posted in the Google Classroom. It's from Khan Academy, and they do a fantastic job summarizing some of these mechanisms. Have a good one.